I'd like to start by talking about money, because materials forms a significant part of the cost base of cable businesses, as you all know, but I just wanted to put the money in context. In 2021, Prismium, in its annual accounts, said that its EBITDA was 7.7%, so its costs were 92.3% of its sales. So costs are a big part of cable making, and manufacturing costs and materials is the significant proportion, probably 70 to 80%. That goes up for commodity cables by a few percentage points, and for specialty cables it might be a little bit less, but still significant amount. So we're talking about a big cost, and a small changes in our scrap and in our overusage of materials, say 1 to 2% on scrap or 5 to 8% on overusage, over and above that which we would expect to see in our costings, would wipe out our profit. So it's, as one of my consultants used to say, it's the difference between two very big numbers, and when one of those big numbers moves a small amount, it has a massive impact. So it's very important for all cable businesses to have absolute control over their materials and their waste. Good material management requires good control, and I've said here control of production processes and control of production. I've just split them just to emphasize a few points. In terms of controlling the process of production, the point at which the material is converted into a subcomponent or a cable, we have to make sure that we're using the correct input materials and the correct semi-finished products. We could well have lots of things on the shop floor that look the same, but have been set up for specific orders, and if operators select the wrong length of conductor or the wrong insulated core, then we could be either end up with a short length on an order we're going to make, and equally then we've also used something that was due for another order, so we end up with a remake for that. So having good traceability of length through manufacturing is important. We've got to make sure that operators have got very clear instructions and very clear quality instructions about how to set up the process, how to monitor the process, how to monitor quality during production, and how to record their data. And if they see a variance, they should be seeking assistance, and absolutely recording all information accurately. And supervision here, in terms of control of production, there's an overlap here. Supervision's got an active supervision responsibility to make sure that operators are actually doing those things to the required standard. And that's just a simple walking around, checking, maybe repeating some of their measurements, because people do what you review, and making sure that we're getting the right data for the production processes just ensures that we've got the right information on which to understand our material usage. Controlling production is more for the production supervisors and for the production managers. So making sure the required tooling is available and it's within tolerance, and that all materials are available for the shift. That's the organizational side of production. We don't want the operators having to hunt for things urgently and then finding the wrong thing and using it. So really got to make sure that it's a very controlled, very visible environment, and that's the responsibility of production and supervision. They have to supervisors have to ensure that process operators understand the objectives for their shifts, what we're supposed to be doing today, what sequence we're supposed to be doing it in, and what we're expecting in terms of performance from them. Use trained staff. Sometimes, unfortunately, we get to a situation where we might use someone who's not fully trained on a particular process. That can lead to errors. Clearly, that could lead to scrap. It could lead to overusage. But it does happen. But again, making sure that staff are trained is a responsibility of supervisors and production managers. When variances occur, supervision and management really has to react quickly to it, and if necessary, stop production. There's no point carrying on making scrap if we're just making length for the sake of making length. Reacting to variance is important. Checking that information is accurate. If the operator's measured a radial thickness and recorded it on his sheet, a supervisor might want to take another sample and just check it, for example. Or check the sample that the guy or girl cut and put onto their shadowgraph or whatever instrument it is they're measuring it. Just making sure that people know that we're keeping an eye on what they're doing means that we really are in control of our material consumption. And it's the role of supervision and management particularly to look for opportunities for improvement. So they should be looking at the data, they should be looking at their waste, and should be identifying where things can be improved. Both operators and managers have a role to play in good materials management. Some basic critical success factors, just trying to boil that lot down a little bit. So minimizing overusage. Design to the minimum possible based on the process capability demonstrated within your plant. Update this over time. So if we have a particular process capability and we have to make a radial thickness a little bit bigger than the minimum because we don't want to infringe the minimum, then that's fine. But if we improve our concentricity or we improve our control and we're capable of reducing that down towards the minimum, absolutely we should be doing it. Use inline measurements and feedback control wherever possible. It's a statement of the obvious, but have we got diameter measurement? Have we got radial thickness measurements online? Are those instruments working? All those good things are just basic fundamental cable making, but it's surprising how often it's the case that those things either aren't working or are on the wrong machines. Gather data, analyze it, learn and improve. We should spend as much time on materials as we do, say, on manpower productivity, which sometimes gets a greater emphasis, even though it's a lower cost. We really should be spending our time looking at our material usage and our scrap and identifying opportunities to improve. A particular one is understanding length optimization in your specific processes. This is when we start off at the beginning with 1,030 meters, we end up with 1,020 meters at the next process, 1,010, and we're making a kilometer for the customer. Just understanding your particular environment for your designs and the losses in length can save an awful lot of materials. And react quickly to variances. Absolutely, every time if we get unexpected scrap or unexpected overusage, we need to take action, because the best time to stop material waste is at the point that it's happening. Minimizing scrap. Obviously, investing in quick changeover techniques for different types of machines. You'll all be aware of what those are. But again, when it's economic to do so, it's not always economic. So if it's not, how can we improve our changeovers to reduce our material waste without those technologies? Planning does play a huge role in reducing scrap in terms of the sequencing of cables through the day to minimize changeovers, particularly on extrusion, as you know, around color changes, polymer changes, and elastomer changes. Those are where most scrap gets generated, and planning and scheduling has a huge role to play there in streamlining those losses. Ensuring that the correct raw materials and semi-finished products are consumed. Again, I mentioned that earlier, that's a basic in terms of making sure that operators are using what we expect them to use and want them to use, rather than something that they decide that they think is best to use. Understanding length optimization, again, helps to reduce scrap. Ensuring quality control and quality management steps are being adhered to accurately. Important active supervision from supervisors to make sure that operators are recording accurate data and that we really do get good information and intelligence about what's happening on the shop floor and reacting quickly to variances. Material management has to be part of an integrated approach to production scheduling, technical management, quality management, and stock control. That all works together to give us control of our materials. And if you get to an accounting period end and you've got a material and the stock control, the stock take is done, and the finance department says you've got a big negative variance on materials, where's all the materials gone? There should have been another 50 tons of copper in the stores and another 40 tons of polymer. Where's it gone? If that's happening regularly in your business, then you haven't got control of materials, and you really do need to get a strategy for getting control.